Hello, good day viewers. In this tutorial, we are going to find a solution to this amazing exponential equation. The equation was sent to me on Facebook yesterday, so I would like to give it a try. X to the power of y equal to y to the power of x. By inspection, you can clearly see that x equal to y is a valid solution. Whenever both x and y have the same values, it will surely satisfy. For example, if y is 2 and x is 2, we have 2 to the power of 2 equal to 4 on both sides. But in this case, we don't want x to be equal to 0 as well as y equals 0. We don't want this situation because 0 to the power of 0 is undefined, which implies that this equation has infinitely many solutions. But if you want to confirm that this equation has infinitely many solutions, we can give it a try. Remember, suppose this equation is a one variable equation. You can just make that variable the subject. But since these are two variables, let us pick one and write it in terms of the other. So let's assume that y is equal to mx, for which this m is just an arbitrary constant. Wherever we have y, we are going to replace it with mx. So we have x to the power of y, but y is mx. This is equal to y, which is mx, to the power of x. Since both exponents contain x, we can cancel it out. So we have only x to the power of m equal to mx. Let us make x the subject. Let's divide both sides by x. So we have x to the power of m divided by x equal to m. Since this naturally has a power of 1, and we have common bases and we are dividing, we can take a base and subtract the exponents, right? This is equal to m. So to take this exponent to the other side, remember this is to the power of 1, we have to multiply both exponents by 1 divided by m minus 1. So this is x equal to m to the power of 1 divided by m minus 1. So this is the value of x in terms of m. So what about y? Remember that y is equal to mx, but x is already this, so let us plug it there. Y will be equal to m multiplied by m to the power of 1 divided by m minus 1. Naturally, this has a power of 1, and since we are multiplying, we can add the exponents. So this is equal to m to the power of 1 plus 1 divided by m minus 1. And if you add this together, it's simply like saying m minus 1 times 1, which is m minus 1, then plus 1, that will give us m. So this is m to the power of m divided by m minus 1. So this is the value of y. So let us play with numbers here. Whatever the value of x and y are depends on m. But m in here and here are exactly the same, right? So let's choose numbers. Let's assume m is equal to 2. Therefore, x will be equal to, remember it is equal to m, which is this, right? Raised to the power of 1 divided by m minus 1. So it will be 2 raised to the power of 1 divided by 2 minus 1. 2 minus 1 is 1. 1 divided by 1 is 1. 2 to the power of 1 is 2. So x is equal to 2. But what about y? Remember, y is equal to m, which is 2, to the power of m, which is also 2, divided by 2 minus 1. So 2 minus 1 is 1. 2 divided by 1 is 2. 2 to the power of 2 is 4. And hence y is equal to 4. So x equal to 2 and y equal to 4. Let us plug it into the main equation. The main equation is x to the power of y equal to y to the power of x. So if we replace x with 2, we have 2 to the power of y is 4. This is equal to y, which is 4, x is 2. Remember, 2 to the power of 4 is 16. 4 to the power of 2 is also 16. So since the left and the right hand side are equal, it implies that x equal to 2, y equal to 4 is a valid solution. But I told you it has infinitely many solutions. You can test other solutions. Let m be equal to 3. x will be equal to m to the power of 1 divided by m minus 1. 3 minus 1 is 2. 1 divided by 2 here, right? And 3 to the power of 1 over 2 is the same thing as square root of 3. So x equal to square root of 3. But what about y is equal to m to the power of m, which is 3, divided by m minus 1. This is 2, right? So this is the same thing as saying the square root of 3 to the power of 3. And square root of 3 to the power of 3 is the same thing as 3 multiplied by square root of 3. Remember, this is square root of 3 times square root of 3 times square root of 3. If you combine 2 together, you have 3. Then we have other square root of 3. So let's check this and see whether it is going to satisfy x to the power of y equal to y to the power of x. X is square root of 3 raised to the power of y is 3 root 3. Y is also 3 root 3 to the power of x is square root of 3. You know, according to one of the laws of indices, you can start with the first power here before the second one. So if you say that square root of 3 to the power of 3, it will surely give you this. That's exactly what we evaluated here, right? So we have this to be 3 root 3 to the power of square root of 3, which is the same thing as 3 root 3 to the power of square root of 3. You see that? You can test as many as possible values of m here on this x and y, then plug it into the main equation. It will surely satisfy. So we conclude that x to the power of y equal to y to the power of x has infinitely many solutions. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.